In the last video, we just learned on how to create an array by some commonly used methods. In this video, let's learn about how we can extract and select the data from an array by indexing and slicing. NumPy and the array can be extended using the standard Python syntax X object. X is the ND array. And there are two main types of indexing available. One is the basic slicing, and the other one is the advanced indexing. Basic slicing actually extends the Python's basic concept of slicing to n dimensions. In our case, or in NumPy's cases, it actually just extends that concept to apply the slicing to n dimensions in the array. And it occurs when the OBJ, the object, is a slice object, an integer, or a tuple of slice objects and integer. On the other hand, for the advanced indexing, is actually triggered when the selections objects, OBJ, is a non-tuple sequence object, or an ND array, or a tuple with at least one sequence objects or ND array. And there are two types of advanced indexings that belongs to integer and booleans. Let's go through the examples to see how we could apply the basic slicing and advanced indexings to extract the value from the ND array. The first example is to use the basic slicing. We create a slice object with the start, stop, and steps notations inside of the bracket to create a slice object to select some value from the ND array. First thing first, we import the NumPy as NP, and then we create a NP array like X, and then assign to call it to X. That is from 0s to 9. And then we can apply the positive slicing without steps. That means we are not going to give the value k for this slice object. We just provide the I and j, where I is the starting index and j is the stopping index. So the start is 1 to the end to 7. And then again, on the other hand, we try to provide a positive slice with slicing with step. That means we provide a value for k. So for every second step, every two steps, we try to extract the value between I and j. Again, so of course, we can also provide a negative slicing without steps and negative slicing with steps. That means we start the value from this very end. That is -1, -2, -3, and so and so. So start from the -7 to a +10. And then for the +10, that means it's the very end value. Let's take a look to see how we could possibly to do that. Now this is the first example, positive slicing without the steps. First of all, we of course we try to extract the value between 1 to 6. So this is the first value. This is a zero index. This is the first index, second index, third index, fourth index, fifth index, and then this is the sixth index, and then this is the seventh index. Remember, this is the stopping index. That means we are not going to count for this one. We need to use 7 minus 1. That is the previous index, previous value. So we have the value from 1 to 6. If we are using these, we assign the slice objects from 1 to 7. We actually only have the value from 1 to 6. We need to minus 1 for the end for the stopping index. So we get the value from the positive slicings from 1 to 6. And then for every two step, every two steps, we just we just take the value for every two steps. So let's see, we get the value for the first one, and then for the second step, we we ignore this value, we jump one more step, and then we get another step from the by using a second step here. And then for the for the negative slicing, now you can see that this is starting from -7 to +10. So this is -1, -2, -3, -4, -5, -6, -7. So starting from 3, and then to the very last value, 10, remember we need to -1. So that is from 3 to 9, you got the value. And then for every two step, we take the value, starting from 3, 5, 7, and 9. We can also work out the positive slicing by default I, by default J, and then by default K. So for example, if we do not provide any value to this I, it will just by default, it will start at the very beginning. If we do not provide any values by for J, it will assume that we are going to take all the values all the way to the end, to the last value. And again, if we just ignore the steps, it will just take step 1 as the default value. So you can see that from 0 to 7, and then this is from the starting from 7 and then until the end. And then for this one, this is just from the first values to the 7th value to the 6th value, and then we just assume the step is equals to 1. This is the ways that we use the positive slicing by default value. And also we can create an array for the row and create an array for the columns, and then put these two arrays into these X arrays to do the indexing as well. But that is for the this is for the advanced indexing. So let me print you the rows and print you the column so that you have a better understanding on what I'm talking about. Let's run it. The first row index, we create a 2x2 matrix that is 0, 0, 2, 2, and then for the second one is 0, 1, 0, 1. Okay, so this is for the row index, and this is for the column index. So we put it into the X and the array. The first value is a 0, 0. We extract the 0, 0 value, that is 0, 0. Sorry, that is a 0. And then the second one is a 0, 1. So 0 row, and then the first value. So we got the 0, 1. And then that's it for the first layer of brackets, or you can say that that's it for the first vector. And then for the second one, that is a set 2, 2, and then the corresponding, that is 2, 2 for the row, and the corresponding column is 0, 1. So we have 2, 0, that is the 2, 0, that is 6, and then we got the 2, 1, that is a 7. And then it will return you a nested list because it will just based on the size of the matrix that we provide. And finally, we can also use a conditions that is a Boolean to identify those values that we would like to have. So for example, we just want to get the value where x is larger than 2, and then we provide these Boolean conditions, which is actually returns you a row index array and a column index arrays that you can see here, where this is the value where x is larger than 2. And then by providing these conditions, providing this row index array and column index array into this x array, it will just return you the value that is larger than 2. So this is the value that is larger than 2. 3, 4, 5, 6, 7, 8. And finally, we can also, for these where functions, we can also provide that provide them with 3 arguments. The first argument is the conditions, and then the second argument is the NP NumPy array. And lastly, is that just in case if the value is less than 2, we will provide a NAN. So this returns you the same dimensions, same dimension ND array, and then by filling in the values with NPN. And of course, you can change these values to whatever you want to just make sure that fits your needs. And that's it for the indexing and slicing. In deep learning, very often we need to deal with the structure of an array. In the next lessons, we will cover some techniques to manipulate the shapes of an array to facilitate the training and learning. See you in the next video.